Welcome to the Explainer. Today, we're diving into a massive industry shift that literally transformed offshore drilling rigs, the switch from DC to AC motors. If you've ever wondered how modern platforms hit those crazy high uptime and efficiency numbers, well, it all boils down to a fundamental shift in motor principles. Let's get right into it. Picture this harsh reality for a second. It's 2 a.m. on a drill floor, you're 90 meters above the waterline, and the driller needs to turn a drawworks drum to move thousands of feet of heavy pipe. Now imagine you have two motors that can do the exact same job, but here's the catch. One needs constant hands-on attention, while the other basically runs itself. Between those two, guess which one these multi-million-dollar rigs eventually standardized on? To figure that out, we really have to look at the direct conflict in their core designs. With a DC motor, the brushes and commutator are wear items. Full stop. They totally rely on physical mechanical contact. But on the flip side, you have the AC motor, which uses this incredibly elegant brushless design. And trust me, this isn't just a minor tweak. It's a completely different philosophy for generating rotational force in one of the most unforgiving environments on the planet. This really highlights the real-world difference. You see, a DC motor's brushes ride right on the copper, wearing away just a little bit more with every single rotation. It sparks, it degrades, and you know what that means? It demands constant, labor-intensive, scheduled maintenance. Now contrast that with a modern, fully sealed AC motor. It's clean, completely closed off, and it represents a totally hands-off reality for a rig's maintenance crew. So you might be wondering, how does that AC motor actually work without those physical connections? Well, it's all about AC induction. An AC induction motor doesn't have brushes, and it doesn't have slip rings. Instead, the rotor gets its magnetic field induced directly from the stator. And that right there is the absolute magic of this technology. There is zero physical contact between the rotating and stationary parts, meaning there's no mechanical power path to constantly wear out. Now, an offshore rig is a pretty brutal place. We're talking corrosive sea air, heavy dust, driving rain, and just constant bone-rattling mechanical vibration. But because the AC motor has no exposed contacts that need airflow, it can be built with a fully sealed enclosure. This closed structure basically acts like environmental armor. It's impervious to salt spray and moisture, and honestly, it handles the heavy shock loading from drilling operations way better than an open, ventilated DC frame ever could. Okay, let's pivot for a second from mechanical design over to real-world operational costs. Think about what we just went over regarding wear and tear. Just a quick check for you. What do you think is the single biggest maintenance saving a rig operator gets from making the switch from DC to AC motors? It is, quite simply, eliminating the brush and commutator system entirely, literally wiping it out. By removing those physical wear items, you completely destroy the most frequent labor-intensive maintenance headache that a DC-driven rig used to face. There's just no more scheduling downtime purely to swap out carbon brushes or resurface a scored commutator. And that translates directly to the balance sheet. On an offshore rig, downtime costs massive amounts of real money per hour. Using DC basically means scheduled downtime is baked right into your operations. But with AC, your maintenance list essentially drops to just checking the bearings and the insulation. Fewer wear parts means fewer maintenance windows, which keeps the drill bit turning and saves an absolute fortune over the rig's operating life. Section 1, Mastering the Drawworks, Performance and Control. When you pair an AC motor with an AC variable speed drive, or VSD, you get this beautiful, perfectly flat torque line that starts precisely at zero speed. Older motor systems usually needed a minimum RPM just to develop their full torque. And on a drawworks, if you have a gap in torque at low speeds, you are seriously risking uncontrolled slip or drift at the exact moment you need the machinery to hold a massive load perfectly still. Which brings us to an incredibly critical win: 0 RPM. An AC motor driven by a VSD doesn't just hit full torque near zero, it delivers and holds its full rated torque at absolute zero speed. Think about making a pipe connection or just waiting on bad weather with thousands of feet of heavy drill string hanging there. An AC motor can hold that full torque continuously for hours or even years without overheating. It's wild. And this just completely changes the game. Before this tech came along, drawworks performance was basically just about raw horsepower. But true performance? It's much more precise than that. It's about delivering full torque right at zero speed. It's having the ability to hold continuous torque without the whole system melting down, and having pinpoint speed control at low RPMs for those highly precise maneuvers. The AC VSD gives you all of that no problem. All right, next up, Section 2, Grid-side Performance and Power Quality. In older electrical setups, managing reactive power was a massive headache. But AC VSDs, thanks to their diode supply units, actually maintain a very high, constant power factor across the entire speed range of the motor. So the drive essentially acts as a shield, protecting the rig's grid from the wildly fluctuating power demands of the mechanical load. So why does that actually matter to us? Well, mostly because of the huge cost and space savings it creates. A high, constant power factor means absolutely no reactive power compensation equipment is needed. Zero capacitor banks required. Rig space is literally some of the most expensive real estate on the planet, where every square meter competes with pumps and tanks, so eliminating all that bulky, heavy power compensation gear is an incredible win for rig designers and operators. Bringing this all together, the paradigm shift is completely undeniable. Coming into this, you might have assumed AC and DC motors were just interchangeable choices. But now you know exactly why AC became the undisputed champion offshore. They are mechanically robust, fully enclosed against brutal environments, and need literally zero brush maintenance. They have unparalleled zero-speed torque-holding capability and provide amazing power quality back to the grid. They are just unquestionably tougher, cheaper to run, and perform way better right where it counts. I want to leave you with a thought to chew on as we wrap up this explainer. We've just seen how removing physical moving contact points completely revolutionized the drilling motor. So if solid-state technology and induction can eliminate this much downtime and cost, what other maintenance-heavy, mechanically complex systems on a rig are ripe for a solid-state takeover? As automation and power electronics continue to evolve, the rig of the future is going to look very, very different. Thanks for joining me, and definitely keep that curiosity fired up.